All right, welcome to The Explainer. Today we're diving into something that's, absolutely critical for modern web development, API security. We're going to break down exactly how you can properly lock down a FastAPI application using one of the best, most trusted standards out there.
So you've done the hard work. You've built this amazing API with FastAPI. Your routes are set up, the logic is humming, but there's a problem. Right now, its front door is basically wide open. Anyone could just waltz in and grab potentially sensitive user data. And that's the big problem we're going to tackle today.
So, here's how to think about it. We're not just writing code, okay? We're building a digital fortress. And we're going to do it properly, starting with a simple outer wall and then adding more and more sophisticated layers of defense. The goal is a truly robust system that keeps our application's secrets safe.
Now, before we lay a single brick, we need to get two core concepts straight. They're the pillars of our fortress. First, there's authentication. This is the guard at the gate asking, "Who are you?" It's all about proving you are who you say you are. Then, once you're inside, there's authorization. This answers the question, okay, you're in, but what are you allowed to do? Are you a guest, or do you have the keys to the kingdom?
Okay, let's dive right in. Our first wall, our first line of defense, is going to be the most basic one. It's called HTTP Basic Authentication. And it's kind of like putting a simple password gate at the main entrance.
So how's this work? Well, it's pretty straightforward. The user has to send their username and password with every single API call. FastAPI has this handy little security tool, HTTP Basic, that just grabs those credentials for us. Then we check them. And see that secrets.compareDigest function? That's super important. It defends against something called a timing attack, where a hacker tries to guess a password by measuring tiny differences in the server's response time. Clever, right?
But, and this is a huge but, here's the catch. You're sending the password over and over again. It's like shouting the secret password across the castle courtyard every time you want to get into a new room. As the official docs point out, it's a great tool for learning the concepts, but you would never guard a real fortress this way. It's just not secure enough for production.
Okay, so obviously that's not going to fly for a real application. We need something way better. So let's upgrade from that flimsy password gate to a much more sophisticated system. Think of it like a magic keycard. We're talking about JSON Web Tokens, or JWTs.
And these JWTs, they're a really elegant solution. It's basically this long, compact string of text that carries information, or claims, things like the user's ID or their permissions. But the reason we can trust it is that it's digitally signed. We can verify that it definitely came from our server and that nobody has messed with it along the way.
Now, a JWT isn't just one big garbled mess of text. It's actually really structured. If you look closely, you'll see it's made of 3 distinct parts, all separated by dots. And each one of these parts has a very specific job to do in our new keycard system.
So first up is the header. It just contains some metadata, like what kind of token it is and the algorithm used to sign it. Next is the payload. This is the juicy part. It holds the actual data, the claims, like the user's ID, and critically, an expiration date. And finally, the most important part, the signature. This is created using the header, the payload, and a secret key that only our server knows. If anyone changes a single character in the header or payload, the signature won't match anymore. The token becomes useless, and we can immediately throw it out as a fake.
Now, this whole keycard system is only as strong as the secrets it's built on. I mean, if an attacker steals a user's password, they can just waltz up to the front gate and ask for their own keycard. Which brings us to a non-negotiable, fundamental rule of security. You never, ever store passwords in plain text.
Instead of storing the actual password, we run it through a special one-way function called a hash. We store that resulting string of gibberish. It's a one-way street. You can't go backwards. You can't reverse engineer it to get the original password. So when a user logs in, we just hash the password they gave us and see if it matches the hash we have on file. We can verify who they are without ever needing to know their actual password.
The great news is we don't have to invent any of this stuff from scratch. The Python world gives us fantastic tools right out of the box. For hashing, passlib with the bcrypt algorithm is the gold standard. For creating and checking JWTs, you've got libraries like Python Jose or PyJWT. And Python multipart is just a little helper to handle login forms. The toolkit is all there for you.
Okay, so we've got our secure hashes. Now, a lot of tutorials you'll see online will store them in a simple Python dictionary in the code. And that's fine for a quick demo, but it has this massive, glaring flaw. What happens when your server restarts? That dictionary gets wiped out. Your entire user list, poof, gone.
For a real fortress, you need a permanent record, right? A proper guest ledger that doesn't just vanish. And that's where a real database comes in. We can use a tool like SQLalchemy to connect our FastAPI app to a persistent database. Think Postgres, MySQL, even SQLite, to give our user data a safe, permanent home.
All right, let's put all the pieces together. Let's walk through the whole life cycle. First, a user registers. We hash their password and save it to the database. Then, they log in at a special /token endpoint. We check their password against the hash, and if it matches, we give them a signed JWT. From that point on, whenever they want to access a protected page, they just show that token. FastAPI's dependency injection system seamlessly catches the token, checks the signature, makes sure it hasn't expired, and grants access. It's clean, it's secure, and it's beautiful.
And this is where FastAPI just shines. It automatically generates these incredible interactive API docs. You can literally go to the docs in your browser, use the login endpoint to get a token, click the little authorize button, paste it in, and then you can test all of your secure endpoints right there. It makes building and debugging this stuff an absolute breeze.
So if there's one thing to take away, it's that real security isn't a single switch you flip. It's a process of layering defenses. We've built a really strong foundation for our fortress with hash passwords and signed JWTs. But you know, a real-world fortress has more going on than just a strong front gate. And this foundation we've built opens the door to much more advanced concepts. Things like, how do you handle different user roles and permissions? In the auth world, we call those scopes. Or what about refresh tokens, so users can get a new keycard without having to type their password in again? And hey, if building all this yourself sounds like a lot of work, it can be. That's why services like Auth0 exist, offering complete, battle-tested security systems you can just plug right in. The fortress is secure, but there's always more to build.